Hello, welcome to the another lecture of control system. I am Mr. Prajit from Asansol Engineering College. Like to giving you some basic or fundamental ideas about control system. From lecture 1 to lecture 2 respectively, I discussed the what is control system, why do we need control system, what are the especially types of control system, that is the open loop control, closed loop control, and little bit examples are already discussed. Now the ensuing slides will be shown to you people depending on the transfer function, because the entire control system is totally depending on transfer function. So at first we will see what is transfer function, and correspondingly we have to generate transfer function based on block diagram reduction rules. And before proceeding further for the complex diagram of block diagram reduction rules, we should have a sufficient knowledge about the block diagram algebra that should be analyzed successfully. Okay, so now we will discuss what is transfer function, and that transfer function is already known to you people. You have studied in signal systems in digital signal processing also 5th semester. Again I am repeating the same. See the left hand side diagram, where the system in time domain is denoted by g of t, input is r of t and output is c of t. So when I am applying Laplace transform on those, it generates the right hand side generates r of s, r of t, the Laplace transform of r of t generates r of s, Laplace transform of g of t generates g of s, and Laplace transform of c of t generates c of s. So what is the basic definition of transfer function? The ratio of the Laplace transform of the output to the Laplace transform of the input under the assumption of zero initial condition is known as the transfer function. Otherwise you can't speak, it is a transfer function. So before starting control system theory, I already mentioned to you people, you should have a sufficient knowledge about the Laplace transform also. And Laplace transform, since that is in S plane, which consists of sigma plus j omega, j is equal to root under minus 1, is complex quantity. That's why I told you people, you should have a very much flexible about complex algebra, because those things will be thoroughly analyzed when I will deal to you people about the frequency domain analysis and complex variables also, that is to be utilized when I will teach to you people about the Nyquist plot, polar plot, etc. Okay, now see, when I am representing g of s, that is Laplace transform of the output variable to the Laplace ratio, that is the Laplace transform of the input variable at time t is equal to 0, that can be written in the form as Laplace, L stands for Laplace transform, so L of c of t by L of r of t, that is nothing c of s by r of s. So this fundamental form should be known to you people. Whatever the topics we need to start in regarding to control system, that is thoroughly depending on the transfer function only. If you know the properties of transfer function, if you know the working principle of transfer function, then easily you can handle whatever the situation regarding to control system it is arised. Okay, now see, here we will determine the transfer function of a closed loop system. This left hand side diagram is very much known to you people. This diagram is already mentioned to you on the lectures 2 slide, where I mentioned the feedback system, that is especially I have been mentioned here negative feedback system. And what is the utility of negative feedback, I already mentioned, because negative feedback always maintains the systems to be stable though the gain is going to be reduced. That's why negative feedback system is also to be known as a degenerative feedback. That means it is known as a degenerative gain. Gain is becoming reduced, but stability is going to be high. Whereas in case of positive feedback system, then we can enhance the gain, that is known as a regenerative gain, but the stability of the system will become reduced. Now see, we are focusing on the negative feedback system, where r of s is my input, g of s is my forward path transfer function, h of s is my reverse path transfer function, c of s is my output. All are in Laplace domain. S stands for Laplace domain, already I discussed on the previous slide. Now h of s is my feedback elements, feedback transfer function, b of s is my feedback signal, e of s is my the error signal, which is to be arised, which is to be the difference between input and the feedback signal. So according to the respective blocks, we can rewrite the above one as C. E of s can be written as R of s minus B of s. Since my B of s gain is negative, we are utilizing negative gain. So on that scenario, I can rewrite the above mathematical equation as R of s is equal to E of s plus B of s. Now the gain of the feedback network, because see, I am focusing now on feedback system where the gain is feedback element gain is H of s. Now my feedback input is C of s and feedback output is B of s. So gain of the feedback network can be written as H of s is equal to B of s by C of s. Now we can write from that above one B of s is equal to C of s into H of s. Okay. Now see, if I wish to determine the gain of the closed loop system, that can be rewritten as G of s is equal to C of s by E of s. That means I am taking the forward path. Keep in your mind. That means I am taking the forward path. Isolatedly, I am evaluating the gain of the reverse path and forward path. Okay, so that generates C of s is equal to G of s into E of s. Now you substitute the value of E of s already available, and here see, substitute value of E of s from equation 1 to equation 3. That means it is nothing, E of s is R of s minus B of s. That thing has been substituted, so it will be C of s is equal to G of s whole into R of s minus B of s, and B of s already you know, that is C of s into H of s. That should be substituted it here, and after substitution from equation 2 to equation 4 the value of B of s, then the respective simplification of mathematics is going on, which generates transfer function of the entire negative feedback system is nothing, that is C of s by R of s is equal to G of s by 1 plus G of s H of s. So this formula is known to you people. There I told you people, on the next slide we will derive. So this is the actual derivation for the negative feedback system. Okay. Now, what is the need of block diagram algebra? If the system is simple and has limited parameters, then it is easy to analyze such systems using transfer function. And if the system is complicated and also have number of parameters, then it is very difficult to analyze it. To overcome this problem, block diagram representation is used. Then it is a simple way to represent any practically complicated system where each component of the system is represented by a separate block known as a functional block. These blocks are interconnected in a proper sequence. Obviously, just you look this diagram, because these blocks are interconnected. If I am taking the blocks are G of s, H of s, these are interconnected in the proper sequence. Summary is available, that is measuring the respective error. Okay, now one thing I need to speak, I am utilizing negative feedback. If my feedback is gain is positive, that means the rest thing is remaining same. The as usual treatment will be remaining same for deriving the actual transfer function for the positive feedback. The thing is different at the denominator. Numerator will be G of s, but for positive feedback system the denominator will be 1 minus G of s H of s. You can verify the same. Now see, these are the block diagram fundamentals. Before proceeding further, before solving the complicated problem regarding to block diagram, we should have a sufficient knowledge about those fundamental things. What is block diagram? It is a pictorial representation of the cause and effect relationship between input and output of a physical system. Obviously, block is my system. I am providing input and output is generated. Output, the value of the input is multiplied into the value of block gain to get the output. Output, if I am denoting Y of s, then A is the respective gain, X of s is my input, then output will be Y of s is equal to A multiplied with X of s. Now summing point, another very big thing, that is two or more signals can be added or subtracted at a summing point. Yes, see X whose gain, if I am focusing this diagram, see X whose gain is positive, Y whose gain is positive, but Z its gain is negative. So output, what will be the output? It should be X plus Y minus Z. It can be n number of inputs with respective signs, whether it is positive gain or negative gain, but the actual thing is remaining same. Now take off point, very important thing for block diagram reduction technique. The output takeoff point is highlighted by the red spot and the red arrow. See, the output signal can be applied to two or more points from a takeoff point. Takeoff point you can speak as a junction. That means in many outputs or many paths can be determined from that, can be shown from that point. That is the junction point, takeoff point. Now forward path, obviously name itself signifies meaning, that is highlighted with the help of arrow and indicated the respective name, forward path. The direction of flow of signal is from input to output. Obviously if my RFS is the Laplace transform of the input domain, my summary is used and that feedback is connected the negative feedback because negative sign is highlighted. Feedback transfer function is H1. Two blocks are in there, G1 and G2, that signifies the forward path system is going on, and C of S is my Laplace transform of the output path. Now feedback path, that is also to be highlighted. Feedback path is mentioned, the direction of flow of signal is from output to input. So this fundamental knowledge should be there, then only you can proceed further. Now the relevant rules to be handled before solving the critical block diagram reduction problem. What is the need? Because we, with the help of block diagram reduction, we may generate the respective transfer function. Here see, rule 1, for blocks in cascade, gain of blocks connected in cascade gets multiplied with each other. What it means, if I am looking the left hand side diagram, see G1 and G2 are in series nature. R of S is my actual input. The Laplace, obviously it should be happening in all Laplace domain. Just think everything is Laplace domain. So several times I will not repeat that same. So R of S is my input, G1, then it generates one output with respect to G1, that is R1 of S, then it will feed to G2, then it is generating C of S. So if I like to eliminate two blocks and if I wish to make a single block, then for cascading nature I can product these two blocks. That means it will be G1 into G2. That means see on the right hand side the equivalent representation of these two blocks. That means I can eliminate two blocks at a time, by which the actual result of the left hand side diagram should not be disturbed, and when I am representing it in an equivalent nature, see the actual result is remaining unchanged. So C of S is equal to G1 G2 into R of S. That result is remaining same. That's why we can speak, we have to represent the diagram in an equivalent way, whether the actual result should not be disturbed. These two blocks can be extended up to n number of blocks. Suppose I am providing you G1, G2, so on dotted Gn are in series, then obviously the right hand side diagram will be R of S should be connected with the product of G1, G2, so on dotted Gn. This will be the product, then the output is generated as C of S. So C of S will be nothing, that is G1, G2, so on dotted Gn for n number of gain products multiplied with R of S. Okay. Now here see, if I am showing this diagram, purposely I made mistake for your understanding point of view. R of S is given to the G1, G2, then another point is provided, that is where the R1 of S is also to be there, then another gain is to be introduced, that is G3, where from G3 output is generated. What is the equivalent diagram for that? If I am looking this diagram on the left hand side, can I club all these blocks at a time based on the previous principle? That means see, I made it first R of S, obviously that is my input, and I clubbed G1, G2, G3, then I am generating C of S. No, it is totally wrong. That's why cross sign, because see, one obstacle is there, R1 of S. If there has no obstacle between these blocks, then automatically this result is correct. Since the obstacle is present, so what should I do for that? So on that scenario, see, at first I will club G1 and G2 based on R of S. See here the right hand side diagram is highlighted. Then R1 of S is there, then G3 is there, then C of S. So in such a way we can proceed further. So before proceeding further, you should have a sufficient knowledge. What should you do? How should you do? How can you proceed further in a tactful way? Otherwise, you may not be able to terminate a result. Now, when the many blocks are in parallel nature, how can you eliminate the parallel path with the respective gains? Whether the gains are positive or negative, that is not botheration. See, R of S is the respective input signal, G1, G2, G3 are the respective parallel paths, parallel gains actually, which generates the signal is R1 of S, R2 of S, R3 of S. R1 of S is positive, R2 of S is negative, R3 of S is positive. C of S is what is? That is nothing. Here see R of S, when I am eliminating the parallel paths at a time, it generates R of S is nothing, that is G1 minus G2, since G2 is connected to the negative gain, that's why minus, so G1 minus G2 plus G3, and that is generating C of S. So C of S is nothing, that is G1 minus G2 plus G3 whole into R of S. Obviously that result is matched with the left hand side result, where see there it is also remaining same. C of S is equal to on the left hand side R1 of S minus R2 of S plus R3 of S is equal to G1 R of S minus G2 R of S plus G3 R of S, and I am taking common, that generates G1 minus G2 plus G3 whole into R of S. Now I hope you have a clear cut concept regarding the equivalent representation of the relevant blocks, where the actual result should not be disturbed, that result should remaining same. Now elimination of feedback path or feedback loop. See here positive negative both feedback paths are shown. So just now I derivate the expression for feedback path, feedback transfer function, so that thing is remaining same. Here G is my forward path transfer function, H is my reverse path transfer function, and rest thing is known to you people. So the equivalent representation, see where the elimination summing point is eliminated, block is eliminated, two blocks, that is G block and H block is eliminated, and directly I can insert the result. If my gain is feedback path is negative, then it will be G by 1 plus GH, and if my feedback path is positive, then it will be G by 1 minus GH. So at that, so the total transfer function will be C of S by R of S is equal to G by 1 plus minus GH, plus 1 plus GH is valid for negative feedback, 1 minus GH is valid for positive feedback at the denominator. Okay. Now negative feedback already I mentioned that thing. See, this thing is already happened, this derivation is already shown to you, nothing else, that is E of S is equal to nothing, that is error function. See, R of S minus B of S, that is the difference. Just now I derived, again I am repeating the same thing, where and C of S is nothing, that is E similar. So B of S can be rewritten as H into C of S. C of S is nothing, that is G into R of S minus G into H of C of S. So after elimination of all those things, we can generate C of S by R of S is equal to G by 1 plus GH. And for positive sense, just now this thing I need to speak, because already I told people several times. See here, same repetition. Previously E of S was R of S minus B of S, now it is E of S is equal to R of S plus B of S, and C of S is nothing, that is G into E of S, that is already known to you people, and I will substitute that value of E of S, that is G into R of S plus B of S, and B of S is nothing, that is H into C of S, and then we will substitute and we will eliminate B of S, all those things, then that generates C of S by R of S is equal to G by 1 minus GH. Okay, so this is valid for positive feedback system. Now block diagram reduction technique, where the summing point associativity law will be maintained. Here see, the if I am shifting summing points from one place to another place, what it will be? Two colors summing points are highlighted, one is red color, another is blue color. See here, R of S is the actual input, red color summing point indicates another B1 input is externally applied input is provided where the gain is negative, and the red color summing point generates the output X, that is nothing, R of S minus B1. Just focus on the left hand side diagram, I am telling about the left hand side diagram. And when this X is fed to the blue color summing point, there another externally applied input signal is provided, B2 with its gain negative, and C of S is output. So what will be C of S? C of S is nothing, that is X minus B2, and X is my R of S minus B1 minus B2. So this result is these results should be unchanged. when I am representing in an equivalent nature that is available on the right hand side. See, here I will start from the blue color summing point. That means I am shifting summing point. Blue color summing point is shifted ahead of the red color summing point. So rest things are remaining same. Whatever with the inputs, outputs, that things are remaining same. Here see, R of S is fed directly to the blue color summing point. B2, obviously the gain is negative. That generates X is equal to R of S minus B2 because the gain was already negative. And that X is fed to the red color summing point. And externally applied input signal is applied, that is B1 with its negative gain C of S. That is also X of S is equal to R of S minus B2, by which we can generate C of S is equal to R of S minus B2 minus B1. So both results are same. That is a way to represent the associative law for summing points. That means we are shifting summing points one after another, by which actual results should not be disturbed. Now shift summing point after block. Yes, original diagram is available on the left hand side. See, R of S fed to G, the transfer function G, then summing point is available. Another externally applied input signal X is provided, that is with gain plus positive. C of S is provided. So C of S is nothing, that is R of S into G plus X. That result should not be disturbed. When I am representing on an equivalent nature, what is my aim? I need to shift this summing point before this block or ahead of this block. That means summing point should be shifted ahead of block G. So what should I do? I can introduce, I can delete any number of blocks at a time, by which I can generate the actual result. Whatever the result is established at the left hand side. So on that scenario, see what I made it. R of S, obviously the input signal, according to the summing point shifting, I have introduced in accordance with the externally applied input signal X, one transfer function, one block that is known as 1 by G, and that should be added in accordance with X, by which the actual output is generated, and actual output is C of S. So it will be generated as C of S is equal to G whole into R of S plus X by G, that is nothing, G into R of S plus X. Okay, so actual result is remaining unchanged. So that thing should be known to you people. Now when summing point is shifting after the block, here see, summing point is available ahead of the block. Now I wish to shift this summing point after this block. What it happens? So for the left hand side diagram, the actual result will be C of S is equal to G into whole R of S plus X, that is nothing, G into R of X plus G into X. So this result should be unchanged. So when I am shifting summing point after this block, that should be C. There I have introduced, previously I have introduced in accordance with the externally applied input signal X 1 by G. Now on the right hand side, see, when I am shifting summing point after the block, then I am introducing the block is G in accordance with the externally input signal X. So that generates C of S is equal to G into R of S plus X of G is equal to G R of S plus XG. So actual result is unchanged. Now shift the takeoff point of ahead of the block or before block. Here see, R of S is there, G of G is the transfer function. Takeoff point means the junction point. From that, one output is C of S, another output is X. So C of S is equal to G into R of S and X is equal to C of S. Obviously same output will be generated, that is G into R of S. So what should I do? See, when I am shifting takeoff point ahead of the block or before the block, there I need to introduce another block G. That's why see, we can generate C of S is equal to G into R of S and X is equal to G into R of S. Okay. Now rule 8, shift a takeoff point after the block. Here takeoff point is available at the input stage where R of S is there and X is also R of S, and block is there G C of S. So X is equal to R of S, C of S is equal to G into R of S. So when I am shifting takeoff point after the block, then it will be R of S, G will be there. Then I need to introduce after takeoff point 1 by G block in which will be in accordance with the externally output, that is C X is generated. So what will be the actual output? So C of S will be remaining unchanged, that is G into R of S, and X is equal to C of S into 1 by G, C of S is nothing, that is G into R of S into 1 by G, that is also remaining unchanged. C R of S. So actual input is generating when I am introducing 1 by G block in accordance with X. So that thing should be in your mind, then only you can proceed further to solve any kind of block diagram problem. Now this is a very good problem. Determine the transfer function for C of S by R of S for the given block by using block diagram reduction rules. So here see, before starting the problem you should have a sufficient knowledge and you should have a quick look where you have to start. So you may start from anywhere, but that starting should carry valid meaning. So what should I do for this type of complicated diagram? See, several gains are available, several summing points are available, two feedback paths are available, H1 and H2 respectively. What about the gain itself? So what should I do? See here see, when I am rewriting this, obviously the respective diagram is provided. So what should I do? Here see, one thing is highlighted, this diagram is G1 H1 is in feedback path, obviously negative feedback, that is negative sign is mixed with the arrow, negative feedback, and G4 G3 G5 are in all parallel paths. So we can choose these things at a time, these two things, that means elimination G1 and H1 feedback path at a time and avoid the parallel path, eliminate the parallel path, that means it should be G4 plus G3 plus G5, and that the elimination of feedback path will be negative feedback, so it will be G1 by 1 plus G1 H1. See, at first I will remove the parallel path by the summing point is removed, that's why it is generating G3 plus G4 plus G5, and that thing I am remaining kept same. After that I will do, then my next job is I need to cascade G3 plus G4 plus G5 with G2, G3 plus G4 plus G5 with G2, because there has no obstacle between G2 and that block. So it will be G2 into G3 plus G4 plus G5. See, then what should I do? I need to eliminate this feedback path that is connecting to G1 and H1, that will be G1 by 1 plus G1 H1. Then again I need to cascade these two blocks, G1 by 1 plus G1 H1 and G2 into G3 plus G4 plus G5, that is the product, that will be G1 G2 G3 plus G4 plus G5 whole into divided by 1 plus G1 H1, obviously. Then see, again we need to eliminate this feedback path which consists of H2 whose gain is negative, that will be G1 G2 whole into G3 plus G4 plus G5 divided by 1 plus G1 H1, then whole divided by G1 1 plus, because negative feedback is there, whole divided by 1 plus H2 G1 G2 whole into G3 plus G4 plus G5 divided by 1 plus G1 H1. So this calculation should be verified by you people. Then after elimination of this feedback path, the resultant should be cascaded with G6, that is in series, that should be G6 will be multiplied, so that ultimate result generates C of S by R of S is equal to G1 G2 G6 whole into G3 plus G4 plus G5 divided by 1 plus G1 H1 plus G1 G2 H2 whole into G3 plus G4 plus G5. So this result should be verified by you people, then only you can be able to learn. By looking the problem, your judgment will be going on. Now next is signal flow graph, SFG. A SFG consists of a network in which nodes are connected by direct branches, number 1. Number 2, it depicts the flow of signals from one point of a system to another and gives the relationship among the signals. Now if we consider a simple equation below and draw its signal flow graph, that is y is equal to ax. So the signal flow graph of the equation is shown as x and y are the respective nodes. Obviously x is my input node and y is my output node, and a is the transfer function or transmittance parameter that should be highlighted, see, just above the arrow. So that is the strategy for drawing SFG. SFG is a highly sophisticated tool. We will see why we are introducing SFG, where the drawbacks can be overcome. Drawbacks can be overcome means drawbacks which are occurred due to the presence of block diagram, that can be overcome with the help of SFG. In case of SFG, we can eliminate summing point, blocks, all those things at a time, and takeoff points also by introducing a node only. Okay. So here every variable in SFG is designed by a node. every transmission function, that is A in this scenario, is this in a signal flow graph is designed by a branch. Branches are always unidirectional. The arrow in the branch denotes the direction of the signal flow. Terminologies: an input node or source contain only the outgoing branches. If I am looking this below diagram, that is x1. Yes, x1 is to be known as the divergent node or the input node or the source node. Output node or sink node or convergent node is nothing, contains only the incoming branches. According to this diagram, below diagram, x4 is my sink node. 4 nodes are available: x1, x2, x3, x4. A path is continuous unidirectional succession of branches along which no node is passed more than once, that is. Okay. And a forward path is a path from the input node to the output node, that is from x1 to x2 to x3 to x4, one forward path. Another forward path is x1 to x2. See, another bypassing forward path is available with the highlighted by black color path, that is x1 to x2 to x4, that is bypassing the point x3, that is also forward path. A feedback path or feedback loop is a path in which originates and terminates on the same node, that is x2 to x3, yes, prominent feedback, and back to x2, x2 to x3 and back to x2, and is a feedback path. And self loop is already available, that is available on the x3 node. Two loops, paths or loop and a path are said to be non-touching if they have no nodes in common. Obviously, if the two nodes are totally isolated with each other, then we can speak those two loops are non-touching or untouched loop pairs. Now, to derive transfer function or net gain from the SFG diagram, we have to take help from Mason's gain rule or Mason's gain formula. That is, the block diagram reduction technique requires successive application of fundamental relationships in order to arrive at the system transfer function. On the other hand, Mason's rule for reducing a signal flow graph to a single transfer function requires the application of one formula. The formula was derived by S.J. Mason when he related the SFG to the simultaneous equations that can be written from the graph. The transfer function T of a system is represented by SFG, that is T is equal to C of S by R of S is equal to summation I runs from 1 to n P suffix I delta suffix I total divided by delta, where n is nothing, that is the number of forward paths, P suffix I is the ith forward path, delta, very important term, that is 1 minus sum of all individual loop transmittance, that is the loop gains, plus sum of the products of loop transmittance of all possible pairs of non-touching loops minus sum of the products of loop transmittance of triple non-touching loops plus so on dotted, that will be sum of the products of loop transmittance of 5 of non-touching loops. In such a way, it will be going on up to n minus 1 non-touching loops. Okay, and delta suffix I calculate same value of delta for ith path, that is equal to 1 minus loop transmittance of single non-touching loops with the forward path plus loop transmittance of pair of non-touching loops with forward path. Actually, delta suffix I is nothing, it will evaluate same value of delta, but it should not touch ith forward path. Suppose I am telling to you, you have to evaluate delta 1. Delta 1 is valid for first forward path. So when I wish to evaluate delta 1, depending on the same formula of delta, we should have a sufficient knowledge to evaluate delta 1 that it should not touch first forward path. That means excluding first forward path, delta 1 value will be evaluated. If we are obtaining all the values are touched with the first forward path, then it will be 1 minus sum of all those terms should be 0, then delta 1 value will come 1. So when we will solve relevant problems, that thing will be very much clear to you people. Now, what is the actual comparison between block diagram and signal flow graph? That is very prominent. Block diagram, see, already I mentioned, that is for open loop system. G of S is the transfer function, R of S is the input, C of S is the output in Laplace domain. Whereas in SFGC, R of S is denoted by input node, C of S is denoted by output node, and G of S, that is transmittance or gain parameter, is highlighted with the arrow direction, and arrow is nothing that is signal flow, where signal is comes from the input to output, and then we can generate the respective gain of that thing. Now the respective assignment is provided. Define the transfer function, very important thing. Determine the transfer function of C of s by R of s for the given block diagram by using block diagram reduction rules. This thing you should have to do. And another, why do we need block diagram, why signal flow graph is needed to determine transfer function, and write down Mason's gain rule for signal flow graph. Now the thing is references. Already I told you people this I am taking help from these very good books. You can study from any kind of books, whatever we wish, and that's all for today. Okay.